Welcome back to the A+ Tutor. In this video, I'm going over all the different features of our quadratic functions and how we can use that to graph our quadratics. So what is a quadratic function? This is a function typically written in the form f of x equals ax squared plus bx plus c and has a shape of a parabola. We can use these different features or characteristics of these functions to solve problems. So if we consider a function that is in the form f of x equals ax squared plus bx plus c, which is our standard form, that function may look something like this or like this. There are a few different things that we use our function to determine. First is the direction of the graph. How do we know whether it opens upward or downward? That's based on our a value or our leading coefficient. When our leading coefficient or our a is positive, then our graph opens upward and has a positive growth. When a is negative, our graph opens downward. So just by knowing the value of that leading coefficient or of a, we can start to picture what this graph is going to look like. Next is our axis of symmetry. We use the formula x equals negative b over 2a to find our axis of symmetry. So this is a vertical line where x is equal to negative b over 2a. This is also used for our next part, which is our vertex. Our axis of symmetry is where our vertex lies and is the x-coordinate of our vertex. So next, the vertex. The vertex is either the highest point or the lowest point on our graph. We use our x equals negative b over 2a and plug that in for x to find the y-coordinate of our vertex. And then this acts almost as our starting point for our graph. Next is our y-intercept. Our y-intercept is found by setting x equal to 0 and solving for y. Vice versa, we have our x-intercept or intercepts if there are more than one, which you can solve for by factoring, completing the square, or using the quadratic formula. So there are a few different ways that you can find your x-intercepts. Lastly, we have our domain and range. So for our domain, your domain is all of your possible x values. So your domain typically is going to be negative infinity to infinity or all real numbers because our quadratic functions go on forever, so they typically span over all of our x's. Now, if you have a function that is within a specific domain or specific set of x's, then that is your domain. But if it's not stated, otherwise, in general, it's usually negative infinity to infinity or all real numbers. Now, for our range, we're going to have two different options. When our graph opens upward, our range is going to start at our vertex and go to infinity, which means the y-coordinate of our vertex starts our range, and then we go to infinity because the graph grows forever. When our graph opens downward, our lowest point on our graph is negative infinity, so we start at negative infinity because it goes on forever in the downward direction, and then ends at our y-coordinate of our vertex. So depending on the direction of our graph, we can determine our range. So let's look at an actual quadratic function and see what all of this means. Let's take the function f of x equals x squared plus 2x minus 8. Remember, if our standard form is ax squared plus bx plus c, our a is 1, our b is 2, and our c is negative 8. So for our direction, we need to look at our a term. Our a equals 1, which is greater than 0. Therefore, our graph is going to open upward. For our axis of symmetry, we use the formula x equals negative b over 2a. So that means x is equal to negative 2, our b is 2, over 2 times 1, which is negative 2 over 2, which is negative 1. So our axis of symmetry is at the line x equals negative 1, and we can plot that line. Now for our vertex, we just found the x-coordinate of our vertex, which is negative 1. We'll plug that in to find the y-coordinate of our vertex from our function. So f of negative 1 is going to be equal to negative 1 squared plus 2 times negative 1 minus 8. This is 1 minus 2 minus 8, which when we simplify that is negative 9. So our vertex is at negative 1, negative 9. Next, we'll find our y-intercept. Our y-intercept is where our x is 0, so we want to find that point on our y-axis. So we'll plug in 0 for x, f of 0. 0 squared plus 2 times 0 minus 8 is going to be equal to 0 plus 0 minus 8, and our y-intercept is at negative 8. Next, for our x-intercept, our y is 0, and for this function we can factor. So our a times c is negative 8. Our factors of negative 8 are 1 and 8, and 2 and 4. We can write those factors, so our factors become x plus 4 and x minus 2. Separating that out, we'll find that we have an x-intercept at negative 4 and at 2. If you want to go over factoring, I have linked the factoring video above, and also how to solve for your x-intercepts, so you can also check those videos out. Now that we have all of these different pieces, let's graph this parabola. For our domain and range, our domain is all real numbers, or negative infinity to infinity from left to right. Our graph goes all the way left and all the way right as our graph goes on. And for our range, since our a is positive and greater than 0, we'll start at our vertex. So our range is negative 9 to infinity. And there's our graph. Let's look at some examples of finding the different features of our quadratic functions and then graphing them. So we have f of x equals negative x squared minus 4x plus 12. Our a is negative 1, b is negative 4, and c is 12. Since our a is negative 1, that means it's less than 0 and it opens downward. For our axis of symmetry, we will use x equals negative b over 2a. So that means x is equal to negative 4 over 2 times negative 1. Which is positive 4 over negative 2, which is equal to negative 2. So our axis of symmetry is at x equals negative 2. For our vertex, we'll plug in negative 2 into our function to find the y-coordinate. So f of negative 2 is equal to negative 2 squared minus 4 times negative 2 plus 12. That's equal to negative 4 plus 8 plus 12, which is 16. So our vertex is at negative 2, 16. For our y-intercept, we'll set our x equal to 0 and solve. So f of 0 is equal to negative 0 squared minus 4 times 0 plus 12, which is equal to 12. So our y-intercept is at 0, 12. For our x-intercepts, we'll factor. So first, before we even want to factor, we'll pull out a negative 1. So our expression becomes negative, in parentheses, x squared plus 4x minus 12. We'll use that to find our factors. Our a times c is negative 12, and the factors of negative 12 are 1 and 12, 2 and 6, 3 and 4. We'll use 2 and 6. So we get negative x minus 2, x plus 6. So that means our two x-intercepts are x equals 2 and x equals negative 6. So now we'll graph our parabola using all of these features. Our domain is negative infinity to infinity. Since our graph opens downward, our range is from negative infinity to 16. It stops at our y-coordinate for our vertex. Next, we have f of x equals x squared minus 8x plus 7. So our a is 1, our b is negative 8, and our c is 7. Since our a is 1, that's greater than 0, so we know that this graph will open upward. For our axis of symmetry, again, we'll use x equals negative b over 2a. So plugging in b and a, we get x equals negative 8 over 2 times 1, which is 8 over 2, which is equal to 4. So our axis of symmetry is that x equals 4. For our vertex, we'll plug in 4 to our function to find our y-coordinate. So f of 4 is equal to 4 squared minus 8 times 4 plus 7, which is 16 minus 32 plus 7, which is negative 9. So our vertex is at 4, negative 9. For our y-intercept, we'll set 0 for x and solve for y. So f of 0 is equal to 0 squared minus 8 times 0 plus 7, or f of 0 equals 7, and our y-intercept is at 0, 7. For our x-intercepts, again, we'll factor. So a times c is 7. 7, the only factors of 7 are 1 and 7, and they would both be negative. So we would have x minus 1 times x minus 7, Setting each of these equal to 0, we get x equals 1 and x equals 7, so we have intercepts at 1 and 7. Now, using all of these things, we can graph our parabola. Our domain will be negative infinity to infinity, and our range, since our graph opens upward, will start at negative 9 and go all the way to infinity. F of x equals negative x squared minus 6x minus 10. Our a is negative 1, b is negative 6, and c is negative 10. Since a is negative 1, that's less than 0, so our graph opens downward. For our axis of symmetry, x equals negative b over 2a, so x equals negative 6 over 2 times negative 1, which is 6 over negative 2, which is negative 3. So we have our axis of symmetry at x equals negative 3. For our vertex, we'll plug in negative 3 into the function, so f of negative 3 is equal to negative 3 squared minus 6 times negative 3 minus 10, which is negative 9 plus 18 minus 10. When we simplify that, we get f of negative 3 is negative 1, so our vertex is at negative 3, negative 1. For our y-intercept, we'll set x equal to 0, so f of 0 is equal to negative 0 squared minus 6 times 0 minus 10. So that's 0 minus 0 minus 10, or negative 10. For our x-intercept, for the last two problems we factored, we went straight to factoring. But for this one, if we try and factor, there are no factors of 10 that add to give us negative 6. We can use our discriminant from our quadratic function to see how many zeros there are. Our discriminant is b squared minus 4ac. So plugging in our a, b, and c, negative 6 squared minus 4 times negative 1 times negative 10 is 36 minus 40, which is negative 4. Since that's less than 0, whenever our discriminant is less than 0, then we have no x-intercepts. If our discriminant is equal to 0, we have exactly one x-intercept, and if our discriminant is greater than 0, then we have two x-intercepts. You can check out this video on the discriminant and the quadratic formula linked in the card above and in the description below. So now that we've identified that we have no x-intercepts and we have our other points on our graph, let's sketch this parabola. Our domain is still negative infinity to infinity, and we see it's below the x-axis opening downward, which is, again, why we have no x-intercepts. For our range, we have, since it opens downward, we go from negative infinity to negative 1, so our range is negative infinity to negative 1. F of x equals x squared minus 4x plus 4. Our a is 1, b is negative 4, and c is 4. Since a is equal to 1, which is greater than 0, this parabola opens upward. Our axis of symmetry is x equals negative b over 2a, so plugging in a and b, we get x equals negative 4 over 2 times 1, which is 4 over 2, which is 2. For our vertex, we'll plug in 2 to our function to find our y-coordinate. So f of 2 is 2 squared minus 4 times 2 plus 4, which is 4 minus 8 plus 4, which is 0. Next, for our y-intercept, let's let x equal 0. So 0 squared minus 4 times 0 plus 4 is equal to 0 minus 0 plus 4, which is 4. For our x-intercept, we can factor. So a times c is 4. Our factors of 4 are 1 and 4 and 2 and 2. So negative 2 and negative 2 will give us negative 4. So our factors are x minus 2 times x minus 2. Setting both of those equal to 0 gives us x equals 2 and x equals 2. So it's the same point for our x-intercept. And that is exactly what our vertex is. So our graph only touches at one point on the x-axis, and that is at our vertex. So now let's draw our parabola. Our domain is negative infinity to infinity, and our range, since it opens upward, starts at 0 and goes to infinity. Let's look at a real-world example using all of these different parts of our quadratic functions in order to solve problems. Andrew is playing fetch with his dog and throws a tennis ball as far as he can. We have the following function, h of t equals negative 4t squared plus 8t plus 7, expressing a function of t where t represents time in seconds and h of t represents the height of the tennis ball in feet. So let's graph what this looked like. Just because we're using h and t doesn't mean our process changes. Our A is still -4, our B is 8, and our C is 7. Since A is equal to -4, our graph opens downward. To find our axis of symmetry, we'll still do the same thing. X equals -b over 2a, which is -8 over 2 times -4, which is -8 over -8, and that's equal to 1. So we'll find our vertex by plugging 1 into our function. H of 1 is equal to -4 times 1 squared plus 8 times 1 plus 7, which is -4 plus 8 plus 7, which is 11. So our vertex is at 1, 11. Our y-intercept is when t is equal to 0. So we have -4 times 0 plus 8 times 0 plus 7, which equals 0 plus 0 plus 7. So our y-intercept is at 0, 7. And then we can find our x-intercepts. 4 times 7 is 28, and there's no two values of 28 that will add to give us 8. So we'll use the quadratic formula to find our x-intercepts. We will need to plug this into a calculator in order to solve this, but our quadratic formula is x equals -b plus or minus the square root of b squared minus 4ac all over 2a. So we'll use that, but with our t. So t equals -8 plus or minus the square root of 8 squared minus 4 times -4 times 7 all over 2 times -4. Simplifying this, we get -8 plus or minus the square root of 64 plus 112 all over -8, which is -8 plus or minus the square root of 176 over -8, which gives us two answers, -0.65 and 2.66. Now for our graph, they're giving us only the first quadrant of our graph. Since we're talking about an actual ball being thrown, there's two things that must be true. Time can only be positive, so our x-axis can only go to the right because we can only have positive time, and height can only be positive. We cannot go into the ground, so we can only have the first quadrant for our y-axis. We can only go up. So that's why our graph looks like this rather than using all four quadrants, because we must be positive in our time and we must be positive in our height. That also means when we look at our two x-intercepts, we cannot use the -1 because we cannot have negative time. So we can only use 2.66 because that's the only value that's valid for this scenario. So for our domain and range, our domain is only from 0 to 2.66 because the graph ends there. The ball literally hits the ground and does not travel any further in this parabola. And our range is 0 to 11 because the lowest point it is at 0 feet and the highest point is at 11 feet. Looking at our graph, we can determine a few things. One, the maximum height of the tennis ball. We know when we think about domain and range, and especially for our range, what our highest value and lowest values are, our minimum and maximum values. So in this case, just by looking at our graph, we see the maximum height, which is our y-axis, is where our vertex is, so the maximum height is 11. We also see that it takes, from Andrew throwing the ball, it takes 2.66 seconds for the ball to hit the ground. So from 0 to 1 second, the ball is rising, and from 1 to 2.66 seconds, the ball is falling. We also know Andrew is pretty tall, or he's hitting a high arc, maybe he's standing on a box, because the starting point for that throw is 7 feet. Thanks so much for watching. I hope you learned something. If there are any topics you want me to go over, please leave them in the comments below. If you like this video, give it a like, and make sure you're subscribed to my channel so you never miss an upload. See you next time.